Let us begin our today's class. So, as you know that we have to discuss about this course within this 4 class. I think you have already lost 2 classes in the last year, December. I joined and I wait up to 40 to 45 minutes, but nobody has joined. Okay, no problem. Let us start. So today we'll discuss about conditional probability. Okay. So prior to this course, you know what is probability? Anybody here?
Yes, sir.
So please answer that question.
So, mean, what is the probability? I think um, it means only possibility. Uh, Whenever we have to calculate, then probability of anything is equal to I think possible outcomes divided by total number of outcomes.
No, no. First, you have to know what is probability. Okay, then we'll go for conditional probability. What is probability? Is my screen is visible to all of you?
Yes, sir.
So when I say what is probability, you have to understood the basic of this. This is called measure of an uncertainty. Okay. So, what do you mean by measure of an uncertainty? How do I measure an uncertainty? It's very difficult to measure an uncertainty. Uncertainty means here I am going to tell a event which is going to be occur. Okay, it is not yet occur. It is going to be occur. Now, what is that? What is the chance that today will rain? Please follow my question. What will be the chance? What will be the chance today will rain? Or today may be a bright sky or sunny shine sky, or you can say that Mamta will get a first class in this course, or she will be the topper of this course. What is the chance that Mamta will be topper in this course? Okay, so the event has still yet not occur, but you are going to predict with a value. Now predict with a value. Okay. So what do you mean by predict with a value? If there is an ambiguity, then you cannot have to measure that one. What is that? Anybody here will say? So let us say that I will say that IGNOU is the best university in the world. All of you will agree or not agree?
So some may agree or may
May
not.
not agree. Very good. Some may agree, some may not agree. What a fine weather it is. Some may agree, some may not agree. Those who are don't like this winter season, they may not agree. Those who are able to like, they will say that it is a good season. Okay, so maybe Akshay Kumar is a good fighter. Are you agree or not agree? You will say that yes, if you like him. If you don't like, then you will say no. Dr. Gupta is a good doctor. Whenever you are going to him and you are asking for medicine, whatever he is prescribing you, you are able to cure, or immediately you have cured. But somebody has gone there, he charges double fees, may not be prescribing in a good medicine, so he may not or she may not say that Dr. Gupta is a good doctor. So if there is an ambiguity, then you cannot predict. Okay. So what I want to say here, a mathematical value you need, a mathematical value. Okay. A mathematical value you need, a mathematical value. What is going on? A mathematical value which is a quantity. If I say you have 90% out of 100, or maybe 9 point scale out of 10 scale, then you will say that yes, you are a good fighter or good actor. Akshay Kumar is a good actor. Maybe Dr. Gupta is score 8.5 out of 10 scale, then you will say that yes, he is a good doctor. Mamta has secured 98% out of 100. She may be topper of the class. Okay. So you need a quantity. Okay. Similarly, to measure an event which is going to be occur, you need a quantity to predict that one. Everybody clear? What is that? That is known as probability. So probability is the measure of an uncertainty. You will say today is 80% chance, 80% chance of rain. Okay, 80% chance of rain. This is the answer. Somebody will say 92% chance of the rain. Somebody will say 12% chance of the rain. Now, how you are predicting these values depend upon your statistics. So, what are the statistics? When you have see that there are dark clouds, winds are blowing, then you will say that there is 90% chance of today's rain. You will see no cloud, no wind, then you will say that no percent or maybe 0% of chances of raining. So my probability or my measure of uncertainty always depends between 0 and 1. Because if the event is has occurred, suppose Mamta has got topper of this class, then this is 100%. That means I have achieved that prediction 100%. If it is not, then it is 0. So 0 and 1 is the boundary for my measure of uncertainty. That means it is a successful event. If the event has occurred, I am predicting that I will be king, then if I made as a king, then it will be 1. If I have not made, then it is 0. So your chances of prediction is it in between always 0 and 1. So we call in mathematics prediction of an event. Event means any kind of occurrence which is going to be measured by you. How you will measure? I already told, with statistical rules, with statistical information. If you do not have the information, you cannot process it. Suppose Mars, some Land Rover, there was a machine which has taken a photograph of the Mars and sent it to our Earth. And people sitting or scientists sitting at the NASA or maybe our DRDO or maybe our ISRO station, where people are sitting and analyzing that photograph, what it is. So you can easily say that if you have prior information, yes, this photograph is a rock or maybe some mountain or maybe some water. Okay, if you do not have the information, then you cannot able to tell that one. You can predict. Are you getting my point? Suppose you are in a zoo, you have already seen the bird before and you know the name of the bird. Immediately you can say that bird, okay, this is the bird. I know. But if you don't know, then you are not able to predict that one. Okay. But if you need that value, no, I need a name for that bird. Then in that case, you have to give a quantity or name which may be correct, which may not be correct. If it is correct, then it is 1. If it is not correct, then it is 0. So it is always lies between 0 to 1. So this is the things that is known as probability. Everybody clear? Very simple word. Probability is the measure of an uncertainty. The event which has not yet been up appeared, but it is going to be appeared. Now there are two type of probability. Okay, conditional and unconditional. What we are going to read is conditional probability. Now what is that? Conditional and unconditional. So conditional and unconditional, there are two things for the probability. Now, so when multiple events are occurred. Now, what is that multiple events? So, what is that conditional probability? Uh, uh, Anybody will say that suppose I want to pick a alphabet from the 26 alphabet, 26 alphabet that you called as sample. Okay, this is your sample altogether 26 alphabet, and you want to pick up a single alphabet which is a vowel. So how many number of vowels you have? 5 vowels. So that is your favorable events. Okay, like I told you that when you are going to predict the rain chance, what is your favorable event? That is cloud, wind. Okay, so how many number of favorable events you have, then which increases your probability. Okay, so if your sample space is bigger and your favorable cases are lower, then you will have a less probability or less chance of prediction. Okay, so here I have 5 favorable cases A, E, I, O, U. So we have a probability of 5 by 26. Okay. Now what is conditional? What is unconditional? Let me say you. Now suppose I have to pick a alphabet out of 26 alphabet where the previous alphabet is a consonant. Are you getting my point? Now I have to pick two alphabets. Two alphabets compared to the previous event. Okay, so there was, I have picked up one alphabet. Here I have to pick two alphabet. Now what is the condition? The condition is that when I'm picking this alphabet, this is my second position, the previous is a consonant. Let maybe T, maybe P, whatever, but the second is a vowel. So that is a condition for this probability, this second event. What is the condition? The previous is a consonant. Okay, now we are rolling a dice, we are rolling a two dice. Okay, because you have already gone through this probability, I am assuming that you have this type of knowledges. So to rolling two dice simultaneously, rolling one by one dice, one after another, is two different events. Okay, it's a continuous event and discrete, discontinuous or discrete event. Okay, two dice at a time, and one dice a time, one after another. Okay, so there are two dice, you throw one dice, then throw next dice, and two dice rolling at a time. There is two different approach. Okay, two different. So one dice at a time means first dice, let us say I have thrown, I have got it, say 4. Okay, now second dice I am going to throw. Okay, so this is the conditional probability. So find out the conditional probability where the previous dice is an even number. Okay, so how do we find out that one? That we are going to read it. Okay, so this was first suggested by many of the mathematician like Markov and other peoples. Okay, so Markov chains and other, we will read it today. Okay, Markov and one famous mathematician, I forgot his name, that conditional probability he has given Bayes theorem. Okay, Bayes, Markov, Bayes, all these peoples have worked on this problem. I hope you understood this what we have discussed. Two dice at a time means suppose I am going to get a number out of two dice is 11. So what are the favorable case of the 11? 5, 6 and 6, 5. Is there any other favorable cases of two dice? Answer is no. So there are two favorable cases. Total number of cases will be 36 because 6 into 6, 36. So this will be my probability. Okay. So getting, sorry, getting 11 out of 36 possibilities. Okay. So getting 11 when I roll two dice at a time. Now I'm going to get a 11 where the first dice will be even number. So this one will be discarded from the favorable case. This one will be included. Okay, but favorable case of this one, I have told you that even number. So 4 may be even number, 2 may be even number. So how do we measure that one? All of you got it or not?
Yes, sir.
So what is that conditional probability? Now we will measure through a formula. Okay, so let me check that whether there is anybody waiting here. No. Okay, so we can proceed. Now, before I go for that, now let me ask you something, that if a box contains 75 good chips, okay, a box contain, this is my box which contains 75 good chips, okay, not defective, and 25 defective chips, okay, 25 defective chicks. You cannot say there are two separate what it is called class, okay. In a box you have mixture of chips, say chip 1, chip 2, chip 3, chip 4, chip 5, and I have given you a statistics that in this mixture of chips of 100, 75 to 25, it is 100 chips, 75% are good and 25% are defective. This is our statistics information we have. Now 12 chips are selected random. 12 chips are selected randomly. You put your hand inside the box and bring out 12 chips. Now find the probability that at least one chip is defective. So find the probability that is one chip is defective. How will find out this? Who will say here? Find the probability that one chip is defective.
12 out of 100.
Mhm. 12 out of 100 is the sample, na? You are bringing 12 out of 100. That is okay. But what about the probability that one chip is defective? That means you are talking about 1200. This is the wrong answer.
So this 1 out of 12.
1 out of 12 is the favorable case when you have 12 number of samples. What is your samples here? Sample space, who will say?
12, sir. Sample space will be 12.
कैसे sample space? Sample, you are bringing 12 out of 100. Yes or no?
Yes, sir. I think that 12 will be the sample space for us, na?
No, no. You, how many type of, say, you suppose you have put your hand inside the bag and you are bringing out. Say that 12 will be combination of C1, cheap ones, cheap 1, cheap 2. I have made number of cheap 1 to 100. Okay. So this is my chips. Now suppose you have bringing out the that 100 as C1, C5, maybe C99, maybe C7, maybe C10, maybe C13, maybe C23. Are you got my point? These are your
Yes, yes,
12s.
yes.
Okay. Somebody else in the class other than you has to pull out C2, C3, C7, C100, C10, C20, like that. That is 12 chips. Somebody else has pulled out C5, C1, C7. So you got how many type of combinations you will have. That is the sample space. So that is what 100 C12. This is okay, or you can write it in this way,
Yes.
112. Got my point?
Yes, sir. Yes.
So this is your sample space. Now, what are your favorable cases? Favorable cases are how many defective chips are there?
25, sir.
25
20.
defective chips. So 25 से एक. So कैसे निकालेंगे? Now the event is at least one chip defective.
25 C1.
Hmm?
25 C1.
But 25C1, okay, so that is actually at question is saying at least one, not exact one. That you have to remember. At least one chip is defective. If I ask you only one chip is defective, then in that case you have correct answer. 25 C1 divided by 112. That is correct. But I am saying here at least one chip is defective.
25 say 12.
No, no. There are two, so many combinations will come na. 25 C1 plus 25
Yes,
C2,
sir. Yes.
25 C3.
See,
So
after.
rather than going to calculate this much, we will first calculate that. Let us find out that no chip is defective. That means no chip is defective. Then rest of the sets are at least one, two, three, four, maybe 12 chips are defective. You got my point? So
Yes,
if you
yes.
go in that approach, then you will have a good answer or good way to find out this question. Okay. So let us find out that no chip is defective. No chip means zero chip. Zero chip is defective. So what is that? Then we have to subtract one from that, because right now we have learned that our probability is maximum one. So
Yes.
what will be the chance of getting a prime number, or what will be the chance of getting a vowel? That is 5 by 26. So what is the chance of not getting a vowel? 1 minus 5
1
by
minus 5
26.
by
So
26.
probability has two actually rules or two properties. What is that probability? Properties. Probability of a certain event is 0 and probability of certain event is 1 and uncertain event is 0. Okay, somebody has joined. Just okay. I got some beep sound. I think somebody has disconnected and joined. Okay, no problem. We'll continue. And the second one is what? Second one is that probability always lies between these numbers, and certain event minus uncertain event, you will get the probability of the uncertain event. That means probability of certain, probability of uncertain, a dash or a bar, is always equal to 1. Yes or no? आज बारिश होगा नहीं होगा, together will be the one. Yes or no? Either it is a dry day or it is a rainy day. So what is the chance of getting rainy day? If it is 5 by 100, then what is the chance of getting dry day? 1 minus 5 by 100, that is 95. Got it or not? Okay. Similarly, we will have that approach here. If I am going to calculate one chip, forget about 12. So let us take 5 chips. So what are either it is a 0 defective, 1 defective, 2 defective, 3 defective, 4 defective, and 5 defective. Yes or no? So if I calculate 0, then rest of the things I will minus, then I will get it. All of you follow or not follow? Then I will repeat here.
Yes, sir. Yes.
Okay. So what I will do, I will now calculate that no chip defective. So how many good chips are there? 75. Now I'm taking 12. So that is my no chip defective. Probability of no chip. So whatever the answer will come, this answer I will subtract from 1. 1 minus 75, 12 and 112, and this answer will be your answer for the probability of getting at least one chip is defective. Everybody clear or not clear? Whatever you solve it, 75 factorial by 12 factorial into n minus r factorial. 75 minus 12, that is 3. 71 will be whatever the number will come. You just simplify this, you will get it. It will be definitely less than 1, whatever the probability will come. Okay. Everybody clear or not clear?
Yes, sir. Yes.
Okay, so now I am going to ask you a question that in a party of 5%, similar to this, then we will go to the conditional probability understanding. Then we'll read about Markov chains and stationary about the Markov chains. Okay, Now, in a party of five, okay. So let me write this. We have a party. How many people are here? Here, you, all of you are here. Uh, Three peoples are here. Okay. So if there are three peoples, we have, let us say, five peoples it is showing. So I will take it five peoples. Okay. In a party of five persons, compute the probability that at least two have the same birthday. Same birthday. Anybody will say there are five persons. Now find the probability that out of this 5%, two is having the same birthday. So what do you mean by birthday? Same day in same month. Yes or no?
Yes, sir.
Okay, so that clarity you must have. If you have an ambiguity, then you cannot predict. Okay, same day means it may be Monday. So if your birthday is on this Monday, my birthday will be on the next Monday, somebody else's birthday will be on next Monday. No, we are not asking for that. What we are asking, we are asking that same month, same day. Okay, so and same date. Okay, so if you have that like that, so uh, if it is same date, then it will be very pinpointing. Same month and same day. Then assuming a 365 day per year, I am not talking about leap years, then it will be more complicated. So 365 days per year, then what will be the probability that at least two have the same birthday? At least, please remember. So you have to I think you have already did it, many of the probability, at least, at most, exact, at least four in the rolling of two dice. So 0 1 2 3, it is better to calculate rather than 4 to 12. Okay, so I calculate 0. 0 will never be come in the dice. It started with 2, rolling of two dice. Okay, एक डाइस में वन, दूसरा डाइस में वन. So they started with one as one, that means two, and maybe three. Okay, so the combination of 2 and 3 will be how many? There will be one combination of 2, whether 1 1, and the 2 1 and 1 2. There will be three combinations, so 3 by 36 will be this side, 2 and 3, and 4 to 12 is the rest side. So 1 minus 3 by 36 will be at least 4 in the throw up two dice. Are you getting my point? Just right now I show you in the previous question. Okay, similarly, at least two persons having the same birthday. Which one is easier for you? You can calculate. Okay, so how do you do that? You are able to find out this or not? I'm waiting for the answer. Huh? Yes. Okay, that means you are not able to find out this one. Then how will do that? Probability, use of probability. So after 45 minutes, somebody is joining. So it is no use. Okay. Okay. Still I allow. Okay. Anyway, probability and statistics are a very important tool for computer. Okay. Why? Because if you process a machine will actually process through some statistical information. Okay, so some statistical information means, what does it means? Suppose you enter to that a room, a unknown room. Suppose you have board into a lodging or maybe hotel, and you got the keys, and where you have to search the keys to open that room. You never search the keyhole in the wall. You have to search the keyhole in the wooden part of the room. Yes or no? Are yes or no?
Yes, sir. Yes.
When you enter to the room, how you switch on the lights? You first immediately look to the left side or maybe right side of that room, depending upon the layout of the room. Yes or no? Immediately adjacent to the door, you search for that room switch box. Then you switch on the lights. Okay. Now think about a robot, that a robot will open the room and switch on the lights. How do you put that information? Nobody has told you that you go and search the keyhole instead of wall, brick wall, in the wooden type of objects, and nobody has told you that you search your switch box adjacent to the door. Okay, you have already prior information in your mind. Since your childhood, you are actually learn that how to open the door. So whenever you have a wooden type of things and you search for the door keyhole, which is middle of the door maybe, okay, then you open it. Nobody search the keyhole at the bottom of the door or maybe the top of the door. Okay, so it is always middle of the door. Why? Because everybody is having a convenient to reach that keyhole. So it is very difficult for older peoples to bend down themselves and search the keyhole at the bottom of the door. And for children also, or maybe for uh, short height peoples, it is very difficult to open the keyhole at the top of the door. Okay, so from the childhood we have a practice that the keyhole is actually middle of the door. So that actually the information we have to put as a what it is called statistical information with a mathematical value to the system, to the machine, so that machines will take that value and process accordingly to behave like a human beings. Are you able to clear?
Yes, sir.
So that how will do. If you are not clear in probability statistics, you will not be a good programmer or good for computer science point of view. Okay, so computer science basically needs, nowadays everybody has a buzzword of machine learning. Machine learning, you might have learned that one. I just think about how you learn. Can a machine learn or not? Okay, so for machine learning and your learning, all statistical informations and probability statistics are required, and similar kind of things we are going to create in machine also. Okay, your correlation between previous data and this data, regression, all are required. Okay, so you think about this. Okay, otherwise, that how a machine will predict, suppose you are going with travel by a airplane. Suddenly on your birthday you are traveling and that plane is announced that happy birthday to Mamta. So you will also surprise that how the machine has known my birthday. So the machine has the capability to predict that one. So for that you have to derive that rule. What? Let me discuss that one, then we'll have a conditional probability clarity. In the afternoon session we'll discuss some more problems. Okay, let me relate that cheap problems, then I will say that what is conditional probability here rather than the birthday problem. Okay, we are given a box of 5,000 chips. Okay, when I say it is chips, it is microchips. Okay, not your eating chips of Lays and Kurkure like that. Okay, so here it is a IC integrated chips or your motherboard chips or electronic chips. Okay, so you have 5,000 electronic chips, and 1,000 are manufactured by company X. So out of 5,000, 1,000 are manufactured by a company X, and the rest of the are by company Y. When I say rest, that means 4,000. This is a total integrated chips or maybe electronic chips. So 4,000 are by company Y. Okay. Now 10% of the chips made by company X and 5% of the chips made by company Y. So this 5,000 is the total sample. So 10% are made by company X and 5% are made by company Y. Uh, are defective. 10% are defective and 5% are defective. Okay. Now I have to randomly choose a chip which is found to be defective and find the probability that it came from company X. This is actually conditional probability. That means I will pick a chip which is a defective chip, find the probability of the defective chip. Condition is that it comes from the X. Maybe you change the condition, doesn't matter. Accordingly, we will find out the answer. So you got the condition here just right now. Find out the defective chip, but previously the question do not have that type of condition. You find out the defective chip. Here I have to find out the defective chip, but it should be company X. So how do we do that? That is actually known as a conditional probability. So let me write this conditional probability with a formal definition, that conditional probability of an event A, given that the event B occurs. Okay, so that means what I am going to tell you, that we wish to define here that A is a event and B is another event. So now I'm going to find out the probability of A where B is the already occur event. Okay. So conditional probability, we wish to define the conditional probability of the event A given that the event B occurs. Now the conditional probability of A given B is represented as like this. Everybody clear? So we are considering the event A where B is already occur. So this is defined as with uh, a way that simple for two event A intersection B by probability of B. Okay, so it's slightly differ from the regular calculation of the probability, that probability of A intersection B is equal to probability of A, sorry, probability of B. Okay, so how do we find out this conditional probability of A with respect to B? That we have to find out this probability of A intersection B into divided by PB. Okay, so A intersection B we have to find out in two ways. Okay, so how do we do that? Uh, probability of B with probability of A condition B, we use multiplication rule. And okay, let me write that one. Okay, so whatever the notes you have, you follow that one. Okay, so we can write with respect to the multiplication rule, probability of A intersection B is equal to probability of B into probability of A slash B, or probability of A with probability of B slash A, uh, where PB is not equal to 0. Here PA is not equal to 0. You will get a clarity when we'll do the exercise or maybe some of the example problems. Okay, and 0 otherwise. Okay, so let us go and discuss the problem with respect to this conditional probability. I hope all of you have understood this. You have not followed me, then with respect to the example right now, we have, you will have a more clarity to that. Okay, So what is our example says that I have 5,000 chips, 10,000 was manufactured by a company X, 4,000 was manufactured by company Y. Out of 4,000, 5% are defective, 10% are defective from the company X. Now I have to pick up a random chips where that chip is a defective one with respect to company X. Okay, so let us write down that one by one with respect to event A, B, like this. Then only you can put it in the formula. Okay, so define the event A as chip is made by company X. Chip is made by company X. Okay. Now B is the event which is chip is made by company Y. Okay. Uh, now we have to find out defective na. So we'll say that chip is made by company X, that is A, and B is the chip is defective. B is the chip is defective. So that we will put it in the formula. Okay. So because we have to find out the probability of A, which is the defective chip, which is from the company X. Okay, so we have to define accordingly. Now since out of we have 5,000 chips, 1,000 are made by company X, so what is the probability of that PA? So 1,000 by 5,000. So this is the probability of getting a chips manufactured by the company X. So how much it is? 1 by 5. Very simple. Now how many are defective in this case? Out of 5,000 chips, 10% are defective. Okay, so 10% of 1,000 will be how much? 100, and 5% of 4,000 will be 200. So there are 300 defective chips. 100 plus 200. 300 defective chips. Clear? Clear or not? Okay. Now, total number of defective chips will be probability of B is will be 300 out of 5,000. It is I don't know whether it will come from company X or company B, but it will be a defective chip. That is probability of B. So this will be 3 by 2020 minus, so 3 by 50. Okay, so how much it is? Maybe 0.06. Okay, 0.06. Clear? Everybody clear or not? Are you having a doubt?
Clear, sir.
Now what is your A intersection B? A is a what we have taken. A is the event chip is made by company X. B is the event chip is defective. Okay, so A intersection B is what? Then chip is made by company X and is defective. Yes or no? Chip is made by company X and is defective. Okay, so what is that? How many chips are made by company X which is defective? Here we have taken 100. So 100 uh, out of 5,000. Total chip is 5,000. Okay. So chip is made by company X and is defective out of 5,000 chips. So PA intersection B will be 0.02. 220 cancel 1 by 50. So this is 0.02. Now we are going to calculate what we are going to calculate, that this is the knowledge what we have now right now gathered, that probability of a defective chips from the company X. So now we have to find out that probability of a defective chip which is from the company X. That is a yes or no?
Yes, yes,
So what will be according to our answer? This will be probability of B intersection A and probability of B
yes.
A. So what is the probability of B intersection A? कितना था? 0.02 ना? कितना निकला था? Right now we
So
have,
that was A intersection B.
so A intersection B and B intersection A are same ना?
Mhm.
Same है कि नहीं? बताओ. Rightly, you have
Yes,
rightly
yes, sir.
point
Yes,
out.
sir.
You have rightly point out, but a union and intersection are commutative in
Yes,
case of set theory. Okay, so this is 0.02, and what about that one?
And
Next
zero
one,
six
uh,
zero point
divided
zero six.
0.06. Okay, so 0.02 by 0.06. So it is 2 by 6. That is 1 by 3. Answer. Okay, clear?
yes, sir.
Okay, so this is called conditional probability. So more I will suggest you to this. Now the point of discussion is here that if this is for only one two event, if you have multiple events, okay, like multiple events means, suppose let me say that this type of probability, what will be your a chance of win uh, in the Ludo game, or measure the chance of your win uh, in a two player game. So I can make this 2 to 3 player, 4 player, 5 player, 6 player, like this. Okay, so what is the chance of your win in the Ludo game in a two-player game? If you throw a 6, then you will win. If you throw a 6, then you will win. If you will not throw a 6, then you will not win. Okay, so there are two players, let us say A and B. Now if A starts the game, okay, now A starts the game, so you should not have any ambiguity. See, I have quantify all this your chances of winning. How will you win? That I will start the game and I will throw the dice fast. So all these informations I am clearly quantifying. Otherwise, I cannot have a prediction. I'll simply ask you the question that what is the chance of winning in a Ludo game without any clarity, then it is very difficult. So what are the conditions I have put? A starts the game and put throw a 6 only when you will win. So now how do we measure this one? How do we measure this one? This is very simple way. Okay, so probability of getting a 6 is how much? 1 by
1
6.
by 6.
Correct. Now A starts the game and there are two player, A and B. So when A starts the game, so A might have the chance of getting a 6. So if
Yes.
A's win, I am going to calculate A's win. This is the probability. Okay. So this is one event. A has got the 6 and win. So is it the single scenario? You might have not get the 6, not get the 6, not getting 6, then your opponent will get the 6. Then that means you will have a failure in that case. So I cannot calculate this in your age win or in your favorable case. I am interested for your win calculation. So this is one scenario. The next scenario will be plus, where you will not win. That means
1
you
by
do
6.
not have the chance of getting 6. The other means the B is not having the chance of getting 6. Then in the next sorry, next what it's called, next chance, okay, or next iteration, you will get a chance of getting 6. So you will get a 6 means 1 by 6. Not getting a 6 is 1 minus 1 by 6. That is 5 by 6. Yes or no? That are
Yes, sir.
five numbers. So this is one case. The other case will be again similar. 5 by 6 you will not get. B will not get. Again A will not get. Again B will not get. But A will get. Are you getting my point or not?
Yes, sir.
So this is one case. This is another case. Then this is another case. What will be the fourth case? 5 by 6 into 5 by 6 into, this is first chance. Then your opponent is also not get a 6. Then you will not get a 6. Your opponent will not get a 6. Again you will not get a 6. Your opponent will not get a 6, but you will get
Then
6.
onwards.
Okay, so that means this is a infinite, na? Are yes or no?
Yes, sir.
That means when you will get a 6, you don't know. But when you get a 6, you will win.
Yes.
Okay. So, how it looks like? It looks like 1 by 6, 5 by square, na? First 5 by square, 1 by 4. Sorry, 1 by 6.
This is
Then, then I will write that 1 by 6 into 5 by 6 square. Then again 1 by 6 into 5 by 6, 4. Then 1 by 6 into कितना आ रहा है 1 2
One
3
by
4 5 6,
6.
5
6.
by 6 to the power 6. Okay, so plus dot dot dot, it looks like what? Hmm, it looks like, if I write, then you will able to say it is a, this is a r,
Geometry
this,
progression, like
it's a progression, geometric progression. It's a uh, uh, arithmetic progression, you can say. It is a geometric progression.
geometric progression.
Yes, it is a geometric progression. AR square, AR4, AR6, like this dot dot dot. So sum of an infinite upon GP. What is the formula? Sum of an GP. So this is 1 by or A by 1 minus R. याद है?
Yes, sir. Yes, sir.
So A by 1 minus R ना कि 1 by 1 minus R.
No, sir. A whole into 1 minus at to the power n divided by 1 minus, sir, I
No,
think.
that is sum of a GP. That I'm talking about sum of an infinite GP. Here it is infinite, na?
Yes, sir.
If sum upon GP is A into R to the power n minus 1 by R minus 1, when R is greater than 1, if R is less than 1, then it will be reverse. 1
Yes, sir.
minus R to the power n and 1 minus R. Okay. That is A into 1 minus R to the power n by R minus, 1 minus R. Okay. So this is when R is less than 1. So if it is a
Yes,
infinite GP, this is A by 1 minus R, I think. The formula is for A by 1 minus R. So what is A here? 1 by 6. Yes or no? Look at that again.
yes, sir. A is
A
1.
is 1 by 6. R is what? 5 by 6 square. है ना? This is my R.
Yes, sir. R.
Then this is R square. 5 by 6 का square 4. This
Yes,
is
sir.
R cube. AR3, AR4, like this way it will go, na?
Yes, sir.
So this will be 1 by 6 and 1 minus 5 by 6 का square. कितना है? 1 by 6, and this is 36 minus 25. So this is 11 by 36. ठीक है?
Yes, sir. 6 by
Then
11, sir.
6 by 11. Okay. So 6 by 11 is your chance, A's chance. What is the B chance of winning? 1 minus 6 by 11. That is 5 by 11. Okay. Got it or not? You have
Yes,
calculated
sir.
it or not? Clear?
Yes, sir.
So what is the probability of getting 6 and you will win the Ludo game? That is 6 by 11. So you have a better chance if you start the game. If you will not start the game, you can see here. Let us calculate. It is easily to be calculated. You have not started the game. What is the probability of A's chance of winning if you not start the game? That means B will start the game. So B will start the game, B will not win. That means 5 by 6. Then B will not win, but A will win. Now next will B will not win, A will not win, then B will not win, then A will win. Then are you getting my point?
Yes, sir.
So this will be like 5 by 6 plus 5 by 6. That means 1 by 6 into 5 by 6. Okay. Then this 5 by 6 cube into 1 by 6. Okay. So then how do we calculate this one? Whether this is a GP or not? I have to keep this 5 by 6 here, and here I will take it as A and AR. Then this is A, this one. This is A, then 5 by 6 cube are my R square. Okay, that means R is this 5 by 6 iska square. It's not coming as a square, no? So it is also GP, but what will be A and what will be R?
A is 1 by 6.
A is 1 by 6, perfect.
R, R is equal to 5 by 6 square, I think.
5 by square 6 स्क्वायर नहीं होगा, स्क्वायर होगा तो दिस
नहीं
इज
नहीं 5 no no 5 cube, 5 by 6 cube.
no, it is not 5 by 6 q. You do one thing, you take a common of this. Okay, that means from this entire series, if you took 5 by 6 common, you will get 1 by 6, then 1 by 6 into 5 by 6 square. The
Yes, sir.
next one will be, so your A is here, A R is 5 by 6 square.
Yes, sir.
So
5 by
it will
6
come as
square.
a GP, which is very similar to the previous event, and it will come as 6 by 11. So you will get a 5 by 11 because you multiplied with 5 by 6. The answer will come as 6 by 11. So you will get it 5 by 6 cancel. So it will get a, you will get a chance of 5 by 11. Then 5 by 6 plus 5 by 11 because
Yes, sir.
this event was already there. So now you have to calculate this one. So you have a lesser chance compared to the previous one. So it is having a better. Are you got it? So
Yes, sir.
similarly, you can try with B's win when A starts the game and subtract this. Okay, see, so that way you can go ahead. Okay, so now what is our point of discussion? Maybe two-player game, maybe three-player game, doesn't matter. What you have to do here, it is 1 by 6, then plus 5 by 6 if it is a three-player game. Then 5 by 6, A chance, B chance, C chance, then A chance. Okay.
Yes, sir. Yes,
But
sir.
but but in case of conditional probability, if you have multiple events, then Markov, the scientist, has predicted a rule which is known as Markov chain. Okay, Markov chain rule. Okay, Bayes theorem and Markov chain rule we will discuss in the 3 o'clock class. Okay, so I'll stop here. If you have any doubt, you can ask me. I hope you understood what is the conditional probability. That means what we will discuss right now. Uh, Okay, what we'll discuss right now, we will uh, mm, uh, present in multiple events. That means A1, A2, A3, A4, A5. बहुत सारा events है. Okay, now if these three has already occurred, then what will be the chance of A1? Okay, got my point. Compared to A, B, now these are a series of event. So that is called as chain of events. So this person has given that formula. We will not discuss that how he has given the formula, but we will use that formula and we will able to know that how to find out the probability of that one. Why we are interested? Because we are able to give some quantification to the machine rule point of view. That you have to understood. Otherwise, without knowing the purpose, if you read it, you will not understood it. Okay. So there are multiple event A, B, C. Now I have to find out the probability of that event with respect to the multiple occurrences. So A intersection B intersection C, maybe D, maybe E. So we'll write that formula with respect to the summation, or maybe I is equal to 1 to n P of probability AI, like that way. Okay, we will discuss that one. We'll have a separate symbol and separate things for this understanding of the Markov chain. Okay, so I'll stop now. If you have any doubt, you can ask me. Otherwise, I'll stop.
No doubt, sir.
Okay. So thank you.
Thank you, sir.